Hi, I am Dr. R. Vivekananda, Assistant Professor, Department of Mathematics and Management Sciences. Today, the course is the lecture on this course, Fourier and Complex Analysis. In this course, the Unit 3, Integration, Complex Number and Power Series. The topic is Cauchy's integral theorems. Definition: continuous of a complex function. Continuous of a real valued function, how we discussed, similarly continuous of a complex function. You are all well known about continuous function of a real valued function. Similarly, here continuity of a complex function means limit of a complex function is equals to function value at that point. Limit of a function value at z tends to z naught equals to function value at z equals to z naught. If they are equal, then the function is said to be continuous. The function is said to be continuous. Okay. Next, derivative of f of z. This is the basic definition of a differentiation of function. If this differentiation is exists, f of z naught by del z minus f of z naught by del z exists, then function is differentiable. Function is differentiable. So that is, the function differentiation is to represented by f dash of z. Analytic function. It's very important. Should know what is analytic function. Analytic function. Okay. The function f of z is said to be analytic at the point z naught if f of z is differentiable at every point in the neighborhood of z naught. So at z equals to z naught, at z naught and its neighborhood, the function is differentiable everywhere. The function is differentiable at this at everywhere in this neighborhood, then the function is said to be analytic. Function f of z is said to be analytic at z equals to z naught if f of z is differentiable at every point in the neighborhood of z naught. Then only the function is said to be analytic function at z equals to z naught. So that is, f dash of z exists in the neighborhood of z naught. Modulus of z minus z naught epsilon is nothing but epsilon neighborhood. Epsilon neighborhood. Epsilon neighborhood. Epsilon neighborhood. Where epsilon is greater than 0. Means with radius of epsilon, we define a disk, means a circle. So in that circle, the function has to be differentiable at every point. Then f of z is said to be analytic at all, at a z naught. F of z is analytic at z naught means f dash of z naught exists. F dash of z exists at every point in the neighborhood of z naught. So these 2 points has to be observed. These 2 points has to be observed for analytic function. Okay. Analytic function is nothing but function has to be differentiable everywhere in the neighborhood of that point. Singular point. Singular point means a point at which a function is ceases to be analytic. Means z equals to z naught. It's a neighborhood we have defined. We have defined the neighborhood. Okay. In this neighborhood, at any point, function is not differentiable. At any point, and in this neighborhood, at any point, the function is not differentiable. That point is said to be a singular point. That point is said to be singular point. Where its derivative not exists. The point at which function derivative not exists. If the function derivative not exists means analytic is ceases now. Analyticity is get ceased there at that point. So that point is said to be singular point. Okay. For example, f of z equals to z square plus 2z plus 3 by z minus 2. Where the function ceases to be analytic at z equals to 2 now. At z equals to 2, the function is not going to be at z equals to 2. At z equals to 2, differentiation of f of z does not exist. Does not exist. Therefore, z equals to 2 is a singular point. Z equals to 2 is a singular point. Is a singular point. Okay. Analytic function and singular point. Analytic function means the function has to be exists its derivative in the neighborhood of the given point. And singular means where the function ceases its analyticity, where the function doesn't exist its differentiability. That that point is said to be a singular point. Now Cauchy's integral theorem. Cauchy's integral theorem. Statement they may ask for a 1 mark, 2 marks in the examination. F of z equals to u plus iv be analytic on and within the simple closed curve C. Let f dash of z be continuous there. Then integration of f of z dz is equal to 0. Okay. F of z is analytic on and within a simple closed curve. Contour is nothing but curve, smooth curve. Okay. On and within simple closed curve, the function is analytic and f dash of z is exists and continuous there. F dash of z exists and continuous there. Then its integration over the closed contour. Its integration over the closed contour is going to be 0. That is Cauchy's integral theorem. Okay. The function is analytic everywhere on and within closed contour, closed curve, and f dash of z is continuous in the closed curve. Then over the curve, the integration of that function is going to be 0. That is what the statement of Cauchy's integral theorem means. No singular point exists. There is no singular point exists. Means completely that function is completely analytic. Then its integration value is going to be 0 in that closed curve. Cauchy's integral formula. When Cauchy's integral formula comes means if there are any singular points present in the neighborhood of a point, if there are any singular points present, then the integration of that function is going to be like this. F of a equals to 1 by 2 pi I into integration over c f of z by z minus a dz. Means C is a closed curve in which f of z is analytic, and z is a point within C. Z is a point within C at which function is not analytic. This is a closed curve. Okay. At this point only the function is not analytic. Okay. So then at this point, at z equals to a, at the point z equals to a, function value defines by f of a equals to 1 by 2 pi I into integration over c f of z by z minus a dz. Means from this the integration over c f of z dz, f of z by z minus a into dz equals to 2 pi I into f of z. This is the f of a, 2 pi I into f of a, mean function value at a singular point. So this is the integration value of the function when singular points are exists. When single points are exists. Okay. F of integration over c f of z by z minus a dz equals to 2 pi I into f of a. Okay, this is the way of finding integration of the function where singular points exist, singular point exists. Then we can use Cauchy's integral formula to evaluate the function value in that curve. Cauchy's integral formula, generalized Cauchy's integral formula means if there are only singular points are exist, we apply this formula. More than one singular points are exist, means n number of singular points are exist. 2 number of singular points are edges, 3 number of singular points are edges. In such case, this is the formula. Nth derivative, this is nothing but nth derivative of f, nth derivative of f, nth derivative of f at a, nth derivative of f at a. This is the meaning of nth derivative of at a is equals to n factorial by 2 pi I into integration over c f of z by z minus a whole power n plus 1 dz. This implies what do you write now? Integration over c f of z by z minus a whole power n plus 1 dz equals to 2 pi I by n factorial into nth derivative of f at a. Means I am bringing this n factorial by 2 pi I that side, then that becomes as 2 pi I by n factorial into nth derivative of at a. So this is integration, generalized Cauchy's integral formula. This we use when there are more than one singular points. Even one singular point is also applicable by this formula. There are only one singular point in such that can also be evaluated using this formula. Okay, this is was Cauchy's generalized integration, Cauchy's generalized integral formula. Okay, this you need to remember. So once again, Cauchy's integral theorem means if the function is continuous, if the function is analytic within on and within a closed contour C, and f of z is exists and continuous there, then integration over c f of z dz is equal to 0. And Cauchy's generalized Cauchy's integral formula is if there are n number of singular points exists inside the closed contour C, then integration of that function over the closed contour C going to be 2 pi I by n factorial into nth derivative of a. If there are n is equals to 1, see, if there are one singular point, then integration over C f of z minus a whole power n plus 1 means 2 dz equals to 2 pi I by 1 factorial nothing but 1 and f dash of a. If it is n is equal to 2, integration over c f of z by z minus a whole cube dz equals to 2 pi I by 2 factorial into f double dash of a, and so on, like this. Okay, let us discuss the problems. So evaluate integration over c. Solution: integration over c z square minus z plus 1 by z minus 1 into dz. So what is the curve here? Curve is mod z equals to 1 by 2. Mod z equals to 1 by 2 is a circle, of radius, of unit, circle of radius of unit with the origin, with center as origin, with the center 0, 0. Now to evaluate integration for the given function, first let us know about whether the singular points exist or not, whether there is any singular points exists or not. To find singular points, you equate here f of z is, here f of z equals to, z square minus z plus 1 by z minus 1. For this singular point is what? What is a singular point? Because singular point means where the function doesn't exist its derivative. singular point. Singular point can be evaluated by equating the denominator equal to 0. That implies z equals to 1. Okay. Now this singular point lie inside the curve, means circle. Inside this curve or outside the curve, we have to check. The singular point, the here clearly known that the singular point lie outside the circle. The singular point lie outside C. Outside C. Therefore, the function, z square f of z equals to z square minus z plus 1 by z minus 1 is analytic. Is analytic everywhere on and within C. Therefore, by Cauchy's integral theorem, by Cauchy's integral theorem, integration over C z square minus z plus 1 by z minus 1 into dz is going to be 0. That's all. Okay. Though evaluate the function value over the curve. So this function value is going to be 0 since the function is going to be analytic. Everywhere. So the function value is going to be 0. Okay. So let us see one more sum like this. So verify Cauchy's integral theorem for the function 3z square plus iz minus 4, where C is the curve oriented along the vertices 1 plus or minus I, comma minus 1 plus or minus I. So here f of z equals to 3z square plus iz minus 4. We have to verify the Cauchy's integral theorem. Means we have to show f of z dz equals to 0. That we have to show along the curve. Where curve is a square. Where the curve is a square with vertices 1 plus or minus I, comma minus 1 plus or minus I. 1 plus or minus I, comma minus 1 plus or minus I. So we will try to verify that one. First, see here, let us draw a curve. I'm just drawing a curve. Here 1 plus or minus I is nothing but 1 comma 1 and 1 comma minus 1. Another point is minus 1 plus or minus I, that implies minus 1 comma 1 and minus 1 comma minus 1. So like this we have 4 points. Let us try to plot 4 points here. 1 comma minus 1 comma 1. So this is minus 1 comma 1. And here 1 comma 1. And here wait, sorry. Small mistake I did here. I will correct it this one. will correct this one. Small mistake I did here. This is x-axis. This is y-axis. Okay. So here 1 comma 1 means comes here like this. This is the point 1 comma 1. And correspondingly minus 1 comma 1 will be here. And here minus 1 comma minus 1. And here 1 comma minus 1. 1 comma minus 1. So you plot the graph. So graph always oriented in a anti-clockwise direction or positive direction. Always the curve oriented in a anti-clockwise direction. Anti-clockwise direction. This is the definition. So I am just naming the points as A. I am naming the points as A, B, C, D. Now I have to evaluate integration. Now I have to evaluate integration. F of z dz. F of z dz equals to integration along AB. F of z dz plus integration along BC. F of z dz plus integration f of z dz along CD along CD plus integration f of z dz along DA. So we have to evaluate integration along these paths and add them. After evaluating those, add them. Okay. Now I am going to evaluate integration along AB. Along AB. Integration along AB. F of z dz, which is equals to f of z means 3z square minus iz minus 4. 3z square plus iz minus 4 into dz. So you try to simplify this first before you try to simplify this first. You try to simplify before going to simplify. So which is equals to 3 into x plus iy whole square plus I into x plus iy minus 4 into dz dx plus I dy. So now you try to simplify this. 3 into x square minus y square plus 2ixy, okay, plus ix minus y minus 4 into dx plus dy, because before going to evaluate the integration you need to simplify and you can evaluate. So here, so 3x square minus 3y square plus 6ixy plus ix minus y minus 4 into dx plus I dy. This is a simplified form of f of z dz. This is the simplified form of f of z dz. Now you try to evaluate integration along AB. F of z dz. So from this, A means what? The point minus 1 comma 1 minus 1 to the point B is minus 1 comma 1, means that is here x values are varying from minus 1, x is minus 1, x is not varying, it is a constant. Okay, and sorry, b is minus 1, b is 1 comma minus 1, sorry, I will correct it here. B is 1 comma minus 1, isn't it? B is 1 comma minus 1, 1 comma minus 1, sorry, B is 1 comma minus 1. So here x is varying from minus 1 to 1 and y is 1, y is equals to minus 1 only. From this dy become 0, from this dy become 0. So therefore this simplified as integration. So x is varying from minus 1 to 1, f of z dz simplified as, so 3x square minus 3y square, y is minus 1 na? So minus 3 you will get, and 6ixy means minus 6 ix minus 6ix because y going to be minus 1, so plus 6ixy becomes minus 6ix plus ix plus 1 minus 4 into dx, because dy is 0, so only dx will come here. So which is equals to integration minus 1 to 1. Now simplify 3x square minus 6ix plus ix is going to be minus 5ix minus 3 minus 4 minus 7 plus 1 is minus 6 into dx. So which is equals to 3 into x cube by 3 minus 5i into x square by 2 minus 6x over the limits minus 1 to 1. So if you substitute upper limit 1 minus 5 by 2 I minus 6 and the lower limit minus 1 minus 5 by 2 I plus 6. So here minus 5i by 2 minus 5 by I by 2 get cancelled. So 1 minus 6 is minus 5. So minus 5 is going to be minus 10. So this is the integration value along AB. So therefore along AB f of z dz value is going to be minus 10. In the similar way, you need to evaluate along BC, along CD, along DA. In the similar way, evaluate integration of along evaluate f of z dz along BC, along CA, CD, integration along DA. Then add them, integration over C, f of C dz plus integration along AB f of z dz, along BC f of z dz, along CD f of z dz, along DA f of z dz. After finding all these values, if you add them, definitely it is going to be 0. That you need to verify. I evaluated along AB. Similarly, you evaluate along BC, along CD, along DA. Add them. That is going to be 0. Then only Cauchy's integral theorem verified, we say. That implies Cauchy's integral theorem verified. Like that you can say, you can write. Okay. Just I evaluated along AB. I have evaluated the value along AB. Similarly, you evaluate along BC, you will get some value. Along CD also you will get some value. Along DA also you will get some value. And add them. This along BC, along CD, along DA, I am asking you to evaluate. And add them all the values, that is going to be 0. Definitely that is going to be 0. So that implies Cauchy's integral theorem verified for the given function f of z. F of z equals to 3z square plus iz minus 4. Okay. So this is the way of doing problems under this. Okay. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.